This is the fundamental holy grail breakthrough needed for access to space, to make humanity a true spacefaring civilization.
In this interview, Musk's main subject is the new 100 million X Prize for carbon removal. But in there, he gets a chance to give us some very important details about the plans for StarShip as the main platform to take us to the Moon and Mars. And not just once or a few times, but on a regular basis. Wait till you hear for yourself the scale of his plans.
StarShip's taking us to the Moon, taking us to Mars.
That's the
And
goal.
it is audacious. Can you compare it to the Apollo?
It is audacious, yes.
Compare it to the Apollo vehicle, the Saturn V, for comparison for a second, for folks to know, get a sense of it.
Sure. Well, I think the thing that's least obvious from when it's on the ground, from the videos and pictures, is the size of it. So, it's going to be the largest flying object ever. So it'll be twice the thrust and weight of the Saturn V.
Amazing.
So that's just from a side, and taller. Including the launch escape tower. So it's a very tall rocket.
This is a very important point. In case you missed it, he said this is going to be the largest flying object ever. If you think of any other airplane you have ever seen, for example the 747, or if you have ever seen the Saturn V in person, or the space shuttle launching into space, this is going to be much, much larger.
120 meters tall.
And because it's so wide,
yeah.
the proportions are obscure that fact, how big it is.
Yeah, you can see in some of the pictures that have been released when it's landing on the Moon, and the people look like ants. It's a big rocket. This rocket is capable of at least 100 tons and probably closer to 200 tons of useful payload to the surface of the Moon. So it's designed to be far in excess of NASA's requirements.
For comparison, the space shuttle had a maximum payload capacity of 27.5 metric tons, and that is for low Earth orbit. It is an order of magnitude lower when going to geostationary orbit. And of course, the space shuttle could never make it all the way to the Moon.
Yeah. And so it's really intended to be something that that can enable a permanently occupied base on the Moon. So we've got obviously permanently occupied base in Antarctica, and it would be great to have one on the Moon as well.
Yeah.
And you can do I think a lot more research if you have the scientists actually there, and we could have some very powerful telescopes. Actually, more important than the size of StarShip is the fact that it is intended to be fully and rapidly reusable.
Yeah.
So this is the fundamental holy grail breakthrough needed for access to space. To make humanity a true spacefaring civilization, we must have a fully and rapidly reusable rocket. Now, we've made some progress in that direction with Falcon 9, where the booster is reusable and the Dragon spacecraft upper portion is reusable. The second stage is not reusable. I would not say the Falcon booster, spacecraft, and fairing, they're not rapidly reusable. Like, it takes a fair bit of effort. We're getting it down to a few months, basically, and soon, I think probably under a month to turn around a booster. Landing out to sea and then having to bring it back, and then sort of taking a month or so to get it ready for launches. Still, I wouldn't call it rapid by aircraft standards. Whereas StarShip is intended to be both fully and rapidly reusable. So the booster comes right back to the launch pad, literally is caught by the launch tower.
Yep.
So it lands and is actually caught by the launch tower arms. That's aspirationally. I mean,
that looks like science fiction.
Excitement guaranteed.
This is a truly revolutionary change. StarShip will not only be reusable in the general meaning of the term, it will actually land back on the original launch pad, making the turnaround time for launch as minimal as possible, much like an airplane, making all refueling and checks at the gate while passenger can reboard. Another important fact you might have missed, StarShip will not have to stabilize itself on the ground when landing like the Falcon 9 booster. It will be caught from the top by the launch tower.
So the booster it comes back about 6 or 7 minutes later, and it's caught. So it's right there, and then caught by launch tower arms and placed right back onto the launch stand.
Amazing.
And then the ship is. I actually want the ship also to be caught by the launch tower. Now the ship takes at least 90 minutes to orbit the Earth.
Yeah.
And we may take more than one. It may take 3 or 4 orbits to get the ground track realigned with the
Landing zone, yeah.
the landing zone, depending on where you are.
Yeah.
But the point is that the ship will come back and land right by the tower, and be placed right back on. And so,
Like a 767, just refuel
Yeah.
and go.
it's intended to be such that the booster can be used, I don't know, a dozen times a day, and the ship
Wow.
the ship could be, you know, like basically every couple of hours, and that's mostly about reloading propellant and mounting the ship, and then the ship could probably be used, you know, probably in theory every 3 hours if you can make the ground track match. But certainly every, say, 6 to 9 hours, or call it twice a day for the ship. And we'll make more ships than there are boosters. So, and I think once we have the floating space platforms, we can position them such that the ship can come back in a single orbit.
Amazing.
So then it could be like, you know, let's say if we can get 3 ship launches per day, that's 1,000 flights a year. Each with 100 to 150 tons of payload.
Now we're talking a real space program.
Did you get that? Elon makes it sound almost trivial. 1,000 flights a year. That's more flights than most commercial airplanes make in a year. I'll leave you now to imagine the not so far future when spaceflight will be as common as taking a commercial flight.